Established fact that lasers are the fastest and most accurate way of aligning rotating equipment. Accurate alignment increases uptime and significantly reduces maintenance and repair costs. So which system is best for you? There are many products on the market, but none matches the ease of use, versatility, and accuracy of Hamar Laser's Stealth Series S680 shaft alignment system. Rather than just talk about the benefits of the system, we decided to show you just how incredibly easy and yet powerful the S680 and Couple 6 software are, and let you decide if it's as good as we say. So let's get started. First, we need to clamp each bracket on the shaft by wrapping the chain around it, sliding a link on the pin, and tightening the knob. Note the extra chain can be folded up using the magnetic tip. This helps to protect the equipment. Next, slide the laser in the target on the posts and tighten the thumb screws to clamp the heads firmly in place. Repeat the same process with the target while making sure to adjust it so the beams of the laser line up with the holes in the dust cap. This pre-aligns the target to the laser and minimizes setup time. Now remove the dust cap, turn on the target, and boot up the tablet. Next, double-click the Couple 6 icon on the Windows desktop to run the software. In the lower right corner, notice the software automatically scanning the COM ports to locate the stealth target. Once connected, the main screen opens and we see the status bar showing Bluetooth signal strength, target serial number, target battery life, and ambient light detector. To start a project, click on the Project Manager icon in the main menu. Then click on the Create New Machine icon and enter the machine name. This creates a standard Windows folder for the machine and saves an emailable project file with a date and timestamp. This helps organize your machines and keeps track of alignment history. Now from the Couple 6 main menu, click on the Step 1 icon to pull up the dimensions screen. Select the coupling and machine types and begin measuring. To enter each dimension, press and hold the entry box to bring up the keypad. Type in the dimension and hit enter. Continue to measure and enter all 4 dimensions to an accuracy of 1/4 inch, or 6 millimeters. Then select the machine's RPM to set the color-coded alignment tolerances, and hit the next button to go to Step 2, Laser Setup. By first having used the dust cap, the laser should already be pre-aligned to the target. If not, Step 2 will guide you through the laser setup to maximize the alignment range of the target. For the vertical axis, arrows show you which way to slide the target up and down the posts, with offset values and screen graphics updating as you adjust the target. For the horizontal axis, arrows show you which way to turn the adjustment wheel on the laser. Since the laser and the target are pre-aligned to the brackets and the target has a 33mm detector, the S680 eliminates the annoying mechanical pre-alignment of the motor, a common problem with our competitors' cheap single-axis systems. Now let's hit the next button and go to Step 3 and check for softfoot. One of the most important aspects of good alignment is making sure the motor's feet are parallel to its base, commonly called softfoot. Checking for softfoot can save you hours and hours of work. You will notice on the screen there are 4 data-taking areas, each representing 1 foot. To get started, make sure all 4 bolts are tight, then click the Record button, which records data for foot number 1. Loosen the bolt, then click Record again. If the foot movement is within tolerance, then the display will turn green. If not, it will turn red. Notice Couple 6 reminds you to tighten the foot and also shows foot 2 is ready to take data. Continue the same process for all 4 feet, following the on-screen instructions. Couple 6 will then identify the foot with the biggest change in alignment value, and if out of tolerance, recommend the shim to fix it. All you need to do is add the shim, tighten the bolt, and retake the data to confirm the soft foot has been fixed. Now let's click Next and go to Step 4 to start taking alignment data. To determine alignment results, it is necessary to rotate the shafts and record data to remove bracket mounting errors. To handle a variety of different data-taking challenges, the S680 offers 5 different methods to record data for both coupled and uncoupled shafts. The most powerful and easy-to-use data-taking method is Auto Sweep. To use Auto Sweep, click the Auto Sweep icon and then click the Record button. Begin rotating the shafts and Couple 6 will record data at up to 16 readings per second, producing hundreds of data points for the most accurate alignment results possible. As the data is being recorded, dots appear in the data indicator ring and color changes to indicate the quality. Red means not enough data, blue means good data, and green means the best. When the shaft rotation stops, Couple 6 automatically starts calculating the alignment results. After reviewing the data, click Accept to save the values of the results table. With Auto Sweep, you don't need predetermined clock locations to take data. You can start or stop anywhere and take sweep data with as little as 60 degrees. With the results table, you can save up to 20 sets of data to check repeatability, which you can save for historical trending. To view the alignment results, highlight a set of data, click on the Results button, and a window will pop up showing the results with the tolerances applied from step 1. Green means the results are excellent, yellow means they're acceptable, and red means they're out of tolerance. To align the motor, close the Results pop-up, click on the shim icon, which automatically saves the data and opens up step 5, Live Move Screen. One of the major benefits of the S680 is our dual plane live move screen that provides 4 simultaneous alignment axes or 2 alignment planes. This means you can leave the shafts at 12 o'clock or any other clock position to align both vertical and horizontal alignment planes without having to rotate to 3 o'clock or 9 o'clock. This is really important on large machines where tightening the bolts can affect the horizontal alignment. In step 5, there are 2 different ways to view the alignment values: gap offset or angle offset. A simple click of the format icon toggles between the views. Notice the title for the angle display changes from angle to gap when you click the icon. For those who like to see the alignment at the coupling, step 5 allows the user to zoom into the coupling by clicking on the view icon to open the view menu and select coupling zoom. To zoom out, just re-click the coupling zoom icon in the view menu and the dual plane view will reappear. One of the most useful features in all of couple 6 is our flip it feature, which allows you to flip the motor image if you find yourself on the wrong side of the machine. No more using the display box upside down. At the top of the screen, step 5 shows the gap and offset values for both the vertical and horizontal alignment planes, all continuously updating with each move of the motor. At the bottom of the screen, couple 6 shows the calculated shim and move values, which also update continuously. Couple 6 uses arrows at the bottom of the screen to show whether to add or subtract shims and which way to move the motor. To align the motor, first you add the shim. Notice how the vertical gap and offset updates as you insert the shim. The motor image also updates to show you which direction you are moving the motor. After that, adjust the horizontal axis of the machine using normal alignment methods. The amount you need to move the motor is shown as foot values at the bottom of the screen. Just as with the vertical axis, the horizontal gap and offset values in the motor image update as you align the motor. Keep adjusting the motor until the color-coded display is turned either yellow or green. Notice when the alignment values are green, the bolts are installed on the feet to indicate the alignment is completed. Now it is important to verify the alignment, so just hit the remeasure button and couple 6 automatically takes you back to step 4 to retake the data. When you're done taking the data, click the results button and verify that all the values are in tolerance. If so, we're ready to print the report. The data is automatically saved, so click the home button to go to the main menu and then click on the print icon. Select the sections of the report to include and whether to print to paper or PDF for email. You can also preview the report before printing. Once the report is printed, you have completed a couple